Basically, the aim of future is to train the fresh grads or the VLSI aspirants to develop their skills relevant to VLSI industry. This company started with 2016, and we are glad to inform you that we have our appearance in many of the states. Okay, so that will tell you in the later on slides. The VLSI term basically stands for very large scale integration. This is one of the integration of the chips, right? But what is the purpose of basically bringing multiple tiny transistors on unit area or the very small chiplet that we need to understand? See, there could be the possibility to design the circuit with managing the things outer the chiplet, or we can integrate the things on the board itself. But when you integrate the many components on the unit chiplet, that is a compact. So certainly we will get a device which is compact in size, and when this is compact in size, the components will be packed together, they will be tied together, so there will be low power consumption. And certainly if there is less or low power, and the components are not so far, so then it will have the faster in speed. So this is what the target of today's scenario also. When we talk about any design, the engineer target to design the any device which is tiny in size, smaller in size, that have very good power efficiency and higher in speed, that is low latency. So these are the major areas, or these are the major key factors that VLSI provides us. And certainly if you pack your circuit, okay, that is automated, you don't need any manual integration, because all these things will be developed by the EDA tool. So manual integration will not be needed much, hence there will be less chances of the errors also. So these are the four key points you can see in slide. Low parasitic, or we can talk about the higher speed, low power, physically small, and no manual assembly. These are the four key areas where the VLSI plays key role, and that's why everyone is choosing VLSI as a technique to design the chiplets, right? If you see about the background of VLSI, this is not new. It started back in 1947. The first transistor was developed. Then after 10, 15, 10, 11 years, the first integrated circuit IC was developed. Then 1965, the Moore's law. Everyone is well aware about the Moore's law. The Gordon Moore was the co-founder of Intel. He gave a certain statement that after every 18 months, the number of transistors on chiplet will be doubled. And the industry is so far, fulfilling the statement of Gordon Moore, right? More than that also, right? We can assume that the speed, the growth of the industry is more than that statement, right? Then 1970, the first microprocessor, that is Intel Skyline processor, came into the picture, and nowadays you can see a lot of advancement has been made in this, uh, area. From 1980 to 1990, the era was of application-specific IC ASICs, where the IC is designed for one specific areas, one specific applications. But again, the thrust of the engineers are not limited to that only. So we are looking for a generalized ICs, right? So nowadays, now we are working on the SOCs, and the revolution is coming towards the AI chip designings. Okay, so from 2010 onwards, the industry is revolving around the SOCs, system on chips, AI chips, IoT applications, many more applications we have for the chips. And you can see the dependency of the chips in human life is increasing day by day. If I just see the survey of one company, the earlier 2 3 years back, one person was surrounded by 100 chiplets, right, in a day. Means he is using 100 chiplets per person. all over globe we are talking about. Now the industry is, wishing to achieve the 200 or 250 to 250 chiplet per person. This is target of the industry. You can assume at what rate the growth is there, right? We see, we start our day and we end our day. From starting to end we are, using multiple chiplets. Okay, we can take our examples, like we start the day, we are just having fans, ICs, the chiplets. If we go to office, then again vehicles that are full of chiplets, right? We use microwaves, or we use freeze coolers that are full of chiplets. Mobile phone, that is the, daily, routine. Basically this is a need of our, that is also the chiplet, right? Watches, smart watches, or the calculators or laptops. So you can see, you are using multiple, chiplets or chips you are using on your own. So if you see about the integration, basically that is basic table that you usually also, you have discussed in the digital design also. Number of tiny transistors, based on that the chip classification has occurred. Density, according to density the chips are divided. So it started from SSI, where only up to 1 to 12 transistors were there, right, which was very initial level. Then we started to dump more transistors, more gates on the chiplet, and that integration named as MSI, medium scale integration, started from 13 to 99 logic gates, or 10 to 500 transistors. And now the era is going towards the, billions of transistors on single unit area, right? So we can just imagine, like latest processors on in mobile phones. If you see Snapdragon from the Qualcomm, they're having more than 10 billion transistors, right? So this is what the density of the chiplets. And we are not limited to only the transistors. Basically we are now thinking to dump entire system on the chiplet. And the size, the die size of the chiplets is, becoming lower day by day. I had, had some news 2 days back that Texas Instrument, they have come up with the tiny, chip, basically for MCUs, microcontroller units, which is lesser in size as compared to the rice. One rice, basically, it's lesser than that size also, right? So you can imagine that how the growth is happening, how dance advancement is happening in the chip designing. Okay, these few pictures. Sorry, am I audible? Is it going fine?
Yes, sir, it is going smoothly.
Okay.
Yes,
So
sir.
some of the, pictures that will, give you the demographic data of this such advancement. You can see earlier 20, 30 years back, you can see the first, image, which is, 5 MB floppy drive only. It was, requiring lot of manpower to load it in the big, space. And nowadays you are, putting 128 or more than 256 GB pen drives, okay, in your pocket. And the advancement is going on. You can, very soon you will be able to use 1 TB or more than 1 TB pen drives in your pocket, right? Similarly, the advancement has happened in the form of computers also. We might have seen the CRTs, we might have seen the CPU separately, we might have seen the keyboard separately, mouse. So that was requiring, large space, and the, mobility was not available for that, portability basically. And the era has changed to now laptops and foldable laptops. Very thin and very small laptops have come with high configurations, with SSD and so many, large processors. So you can see the advancement. These all are advancements of the VLSI engineers only, right? But the question comes, who are doing that? The VLSI engineers. What are the VLSI engineers areas where they are working on? Which companies basically deals in this, VLSI? So the application areas of the chiplets basically are not limited to one area only, or one specific region only. We can see multiple different areas are there where these chiplets are used, there where the semiconductor chips are to be used. We can see a lot of applications are there in healthcare, right? Suppose pacemakers is one of the example, robots are one of the examples, right? Telecommunication, lot of advancements are going on. You can see the modems, 5G, 6G technologies, these all are basically the using this chips, all okay, fast high speed chips, right? Bluetooth and all. Automotive industry, total dependent on the chip industry only. We might have heard, in 2020 or 21 when the corona period was there, right? Okay, the waiting period of the vehicles were very large, right? More than 1 year, because that time we were dependent on the China, right, or USA for the chips, right? So the all the automotive chips were manufactured and provided by the China or some other countries, Taiwan or USA. Okay, so this is what, you can see the vehicles basically are having EVs, electric vehicles, that is having load of chiplets, sensors and all. So that's why the government has initiated to become self independent on the chip industry also, and a lot of efforts are made in this field as well, right? We can see a lot of government initiatives are there. IESA is taking care of this chip industry. The semicon India has had happened in Greater Noida with the vision to grow the industry in next 5 years at the level beyond the imaginations, right? So a lot of opportunities are being available in this chip industry. We can see the consumer electronics that we talked, daily life electronics, or the items that we are using. We are the consumer as a using, like mobile phones are the boon of chip industry. Fridge, ACs, these all are consuming the chiplets, right? Okay, so everywhere you see the chips are there. Okay, so if you see the semiconductor industry, okay, the semiconductor industry is having 580 billion industry, and it's more than that. This data is around 2021 or 2022. Now 3 years has gone, so this is increasing at the rate of 12% CAGR. So you can assume that this is more than 800 billion industry in across the globe. Okay, there are lot of requirement of skilled engineers. You can see here more than 3 lakh engineers deficiency is there in the chip industry. But I'm just concentrating one word, that is skilled engineers, right? Because the industry requires purely a skilled person who has certain knowledge of the industry. Okay, we can't recruit anyone who doesn't have knowledge, because the chip industry require the very good amount of precision, right? We can't tolerate even 0.0001% of the error. So you can see we need a seasoned person to work with us. So that skilled person, the trained persons are needed. Okay, chip shortage, that I have taken example of the automotive industry as well. Still, India is facing a lot of chip shortage. If you go to buy a car, right? If you go to buy some other equipments that are consumed, that are having chiplets, they have shortage of that. They have some waiting period because the chips are manufactured outside the India. So soon we will be able to see that India is also, we will be able to manufacture the chiplets, right? Earlier, the India was, assumed to be the large supplier of manpower in fabless industry. But now the revolution has happened. We are now moving towards the, fabrication as well. If we see the packages as well, right? The VLSI engineers are the highly paid engineers in entire industry. We see IT engineers, we see any other, manpower. The salaries of the VLSI engineers are very high. Initially, maybe you can get less amount because they need certain time to watch your performance, right? But once the performance is good, once you are assumed to be a good candidate, the money is not a problem for industry, right? And the industry is growing on minimum CAGR of 12%, as I told you. This is a gross annual rate, that on that it is increasing. Means you can assume that suppose 100 rupees is today's cost, then 112, will be the evaluation, the cost of the next year. So that speed it is increasing. If you see the ecosystem of entire semiconductor industry, the entire semiconductor industry is divided or works in two phases. The one is the chip designing and another one is the manufacturing. Basically this part is the fabless, right? And this part is a fabrication, right? So earlier we were assumed to be a good fabless suppliers, right? We were having a lot of manpower in verification, lot of manpower in the physical design as well. Okay, but now the progress is going on in this direction as well with the initiative of government, right? So industry is divided into two phases, works in two phases. The one is manufacturing, in this the fabrication, packaging and automatic test equipments, eight basically this happens. And in chip designing, basically that is the fabless. The fabless is again further divided into two parts, pre-silicon and post-silicon. Pre-silicon, that is basically the process before when you touch your chip basically, right? So wafer, because until unless the wafer comes into the picture, that process is known as the pre-silicon. And post-silicon, after the picture, after the wafer introduction, right? Once wafer comes into the picture, that process comes under the post-silicon category. And again, pre-silicon categories are divided into further front end, back end, DFT, EDAs, all many more things are there, right? Okay, so that is basic top view of your semiconductor subsectors in which the different manpowers are working, right? If you see the chip design flow, right? Because this is not a easy process. This is not a one day process. This involves a lot of manpower, lot of money involved in that for designing or developing one new chiplet, right? Okay, so when you look for this, the first and very important part comes, that is the specification and architectural planning. Basically this is from the customer side. Like suppose I am the customer, you need to understand this is very important slide for everyone as a technical persons. So whenever any chip is designed, right, so there is a requirement from the customer side, there is a requirement from the market side. So the team basically evaluates the requirement and they come up with the architectural description of that chip basically, right? Okay, so that is the work of the architects that are working in this area. So this was the process basically involved in entire chip designing. And the first step starts with the specification, then the customer requirement. Then we go for the RTL designing and verification. Basically, this comes under the front end. When you talk about these two steps, that is coming under the the front end part, where we are writing the code in VHDL or Verilog, that is hardware description languages. Parallelly, we see whether my design is verified, it's functionally correct, or there is no bugs. Until unless we don't have any kind of bugs, then only we move further, right? Once we are very sure that we don't have any bugs in my chip, then we go for the synthesis, which is basically converting my design, that is RTL code, into the gate, and then it is packaging, means optimizing my design. So synthesis and logic optimization basically takes place. Once this logic optimization has been done with the help of synthesis, that is the work of EDA tools, then we go for the physical designing. That is all process involved, that is physical designing. So in physical designing, we go for the placement, routing, floor planning, and so on, right? Just let me just write few names, right? So placement is one of the step that we do. Then floor planning is one of the step that basically plan where we can keep my design. And then PNR, basically routing also, right? Many more things are there, that's clock tree synthesis, STA, and PV, physical verification. These all comes under the physical designing. Once we are done with the physical designing, this all are up to here, these all are tool based, basically automated. The manual integration is very less, automated, because this is all tool dependent, right? Then we go for the fabrication, where we this silicon wafer come into the picture, because up to now we have GDSII, that is the graphics design schematic, and that GDSII is sent to the fabrication department, and that that film is dumped on, or the circuit has been made created on the silicon wafer, and then further process comes under the packaging testing, and finally we come up with the chip that is in our hand, right? So this process is intensive process which require lot of manpower on each and every step. This is looking very simple, but it's not as simple as it's the picture is depicting here. It requires lot of efforts, lot of manpower, lot of money, lot of time as well, right? Okay, more detailed flow we can assume, or we can understand like this. Okay, suppose I have the product requirement from the customer side, so then I freeze that requirement and I just plan the architecture for that, right? So that architectural planning is basically all manual, and this is also manual. That all manual requirements are coming. So far we don't have any automated process to get the requirements from the customer or design the architecture. So these all are done with the manual, only paper pen. So knowledge of digital here is playing pivotal role whenever we do the architectural planning. Okay, so digital design concepts are very, very useful, or analog design concepts are used depending upon the type of chip. Microprocessor is mostly used, or microcontrollers are mostly used, right? We come up with what design. That design has to be implemented on the RTL codes, that is HDL or HVL. So mostly we use here HDLs, hardware description languages, which are meant for designing our architecture, or converting our architecture in soft form. Okay, so mostly we use VHDL as a programming language, or Verilog as a programming language, you must be well aware. And now some advanced languages has come into the picture, that is system Verilog, right? So system Verilog also can be used for the hardware description languages. Okay, in that we have to keep in mind that my code should be synthesizable, so that I can convert this code into the hardware, that is synthesizable code basically. Parallelly, along with that, we need to verify our design also, whatever the code has been written. So this is a integration between the design engineer and the verification engineer. They fight for each other, right? If suppose some design has been developed by the RTL engineer, the verification engineer checks whether the design is perfectly fine or not, it's working as per our expectations or not. If it is not, then it will report to the design team, no, no, your design is not perfectly fine, kindly check, these are the bugs. And this process, this communication basically happens till we don't have any bugs, means we want zero bug chips, right? Okay, once we are very sure that your design having no bugs, we go for the synthesis, that is basically converting my code into the gate basically, right? So that net list is created by the synthesis process, which further optimize through the placing and routing, floor planning, and so on, and we come up with the final IC, that process I involved in that. So I hope this slide is giving you a clear cut picture basically how this chip design flow takes place, and what are the integrations, whether we have the manual integration in that, or whether we have the software based work for that. So mostly you can see here, mostly work in the entire chip design is done with the help of EDA tools, or this is software based. This is purely automated process. Sometimes it's a hybrid, basically we can take some manual help also, sometimes we can take the help of software as well, right? Okay, so up to this process, which was fabulous, basically the India was very powerful. India was already powerful in that. Now India is becoming powerful in this area also. They want that we should develop our own chips, we should fabricate our own chip. So a lot of industries, lot of fabrication laboratories are being developed with the help of Indian government, and IESA, SAFL, these are the organizations which are playing pivotal role, right? If we see the entire chip design flow, I'm just talking about the this uh, fabulous design flow. This is further divided into two parts, front end and back end. So when you talk about front end designing, which involves the architectural, that is specification and architectural description, then we go for the RTL design, then we go for the verification, which is just linked with each other. Emulation basically kind of verification only, but that is hardware verification kind of thing. And then we go for the pre-silicon FPGA validation, right? Which we are just ensuring our design is perfectly fine in terms of the results, or in terms of working principles, right? Whereas in physical design, basically the physical design or backend process starts from the synthesis, where we are converting our design into netlist, which is further planned for floor planning, placement, routing, CTS routing, and all these things have to be done, and we get a GDS II. That's why this is known as, if you understand the complete flow from RTL to GDS II, you are able to understand the entire chip design flow, right? So RTL is the very first step after the architectural planning, and the GDS II basically is the last step in the fabless. So this is entire fabless process basically, which is basically sent to the fabrication industry, and we come up with the silicon wafers, and the packaging and everything is done after that. Okay. So just a case study I'm taking here to explain you the entire chip design flow, the approaches basically which we will be using as an engineer. So like suppose I have a customer that have some requirement in the vehicle. So the first thing that comes in our mind is a system. Basically, this is having multiple chips on the boards, then connections and everything. Okay, so this is what the application layer of my design. This is what the requirement. That is the very first step. The customer requires this thing. Now, as an engineer, I will think about this system which is required by the customer. Let's say I'm just talking about the chip to be manufactured for the electrical vehicle with a lot of sensors. So I need to think about the sensors. I need to think about their interconnections. I need to think about the data calibrations, that from where the data will be taken, and how the data will be processed, and what decision has to be made. So this process, this system will be designed in our paper pen, or maybe in software as well, layout. Okay, so when you just think to implement entire system with the HDLs, we go for any of the modeling style, but mostly as a synthesizable design, we go for the RTL. That's why mostly we use RTL, because behavioral modeling style that we choose, this is like a behavioral description of our hardware, may or may not be synthesizable sometimes, right? Okay, then once the RTL design is complete and its verification is completed, as I told you that implementation, design and verification, we go for the gate level. Gate level basically is converting your RTL to gate level through synthesis process, right? And in which we do the optimization also. Basically, this gate level, the entire system, like the mux based circuit will be designed with gates, and then further you go for the lower level abstractions, right, with the transistor level, and finally we come up with the layout, right? So this is what the top down approach that entire industry uses. We started with the entire complex system. We break down our system in RTL. We designed RTL systems. We integrated it. Then we went for the gate level, that is synthesis, and then we again went for the transistor level, which is the physical design, and finally we come up with the wafer. The chip, the entire system on the wafer, silicon wafer, right? Okay. So this is a case study that we normally follow this approach. There could be multiple other approaches also. I am taking very simple approach that you can understand in your daily life, right? Okay. So these are some piece of processes that we deal, like after developing your entire system on paper pen with architectural description, we go for the RTL design. Like suppose I'm using this as a very low code, very simple code, which is having AND operation or operation and all. Then this RTL code needs to be verified. So at this juncture, RTL, the VHDL, Verilog, and System Verilog are used for development of these RTL codes. Once we are having good design with us, that is in soft form, we verify our design. That verification or simulation we call it as. So that is what ensuring that my design has all functionalities, or all functionalities have been implemented in the designs or not. There are no bugs, means ultimately my objective is to get a bug free design. So making sure that our design doesn't have any bug, and we are ensuring that if some external errors are injected in my design, some external improper behavior is given to my design, then how it behaves. Because ultimately in specification of your chip, we have to mention that it's perfectly fine with these areas, but if you do this kind of alteration, definitely certainly it will be harmful for you, right? So some warnings has to be given also. So these are the verification process that ensure that you are giving a very good design. See, if you are verifying your design with the deep level, with entire coverage and assertions, you will be having a very good design, and the reliability of your product will be very very high, right? So in verification, basically we mostly use system verilog as a language, and the methodology that is adopted by the engineers nowadays is universal verification methodology, right? These basically you need to concentrate, because these are the skills that every engineer who is aspiring to enter into VLSI industry needs to grab it, right? And once the verification is complete, that RTL design needs to be converted into gate level, as I told you. So synthesis will take place, which will be converting your RTL code into the gate level, and then that gate level will be optimized. So you can see here, if I just look for this three set of operations which can be implemented with basic logic gates, but I need to make a compact design, so I can replace the entire circuit. The cost of the circuit was very high, the area was very high, so that can be done with the help of only one gate. So you can see that process has to be designed, that process has to be adapted to get a very compact design, very packed design, and efficient design. After synthesis, that net list, whatever the packed design, is to be sent to the PD department, and the further process, this gate level design needs to be converted into transistor level designs, right? And then we go for the GDS-II. So I hope these three slides are giving you the complete picture, basically, of your entire chip design flow. How basically we follow the process, and what are the tools, what are the languages we use to develop, to create our own design in HDL, right? Now, see, I told you that the RTL design and verification, they are backbone to each other. Until unless the verification engineer doesn't say that your design is perfectly fine, it won't go further, right? Because you see, if you don't verify at the early stage, and we come up with the bug at the end of a development, that your design has certain bugs, then what will happen? The entire process has to start from the scratch only. So you can see the lot of manpower which was involved in the entire designing process, the money was involved, the time was involved, that all is wasted. So hence the nowadays verification is becoming so important. It's very crucial for the entire design cycle. Okay, so what is the very important facts that verification to be done at the early stage? The first one is ensuring the correct functionality. If you don't verify, we will be not sure, we will not ensure that my design is perfectly fine. So we, with the verification, we are ensuring that my design is accurate, accurately behaving like expectations, what we have expectations. This is reducing the development cost. You can take an example, like suppose I am not verifying my design, one design cycle without verification, and one design cycle with verification. You feel that the design cycle without verification might reduce your cost. Again, you are not verifying. At the end, if you get to know that your design is having certain bugs, definitely you have to go back to first step. But if suppose you are verifying at every stage, then you will be very sure, you do not have to go back, right? At there only you will be just doing all processes. So it will be reducing the development cost, time efficiency, definitely, because as I told you, when from starting to end, that design specification to the final chip packaging and all, this requires a lot of time. And if you don't verify at any state in between, in intermediate state, then certainly it would require a lot of time to design entire chip, right? Enhancing the design quality, that is one of the factor, that's the reason verification is to be done. Mitigating risks, we don't have any kind of risk if my design is perfectly fine, it's fully verified. Otherwise there will be always a question in our mind, oh, if it is not verified, then there could be a risk of like suppose I'm taking an example, I design a robot and it is not verified, and then I send this robot to do the operation. So there will be always a kind of risk, basically, that whether he will be performing the right operation or not, right? But if it is fully verified, in every scenarios, then certainly I don't have any kind of doubt on the particular robot, right? And definitely the verification is having the compliance with industry standards also. Many chips basically they are strict to industry standards, so verification will be helping us to ensure that all the compliance requirements from the industry are meeting us or not, right? So these are the few factors. Because of that, we usually, so as I told you that for verification purpose, the system verilog is a programming language, or the basically the main pillar that to be used. So system verilog have several advanced features as compared to the HDL. Just for the sake of your knowledge, I'm just telling you. So some HDL features were there in the Verilog which were not included. So system Verilog have the inbuilt concept of object oriented programming, which will be enhancing our reusable concepts. They will have the coverage, functional coverage. We will be ensuring whether my design or my test bench have covered all the specifications which basically required by the customers or not. Assertions, basically this is for the formal verification that ensures whether my design is perfectly working fine in these applicable scenarios or not. If doesn't work fine, then it should throw some errors, some intimation to be given to the customer that your design is not as per the requirement, right? Some lot of improved data types are there, synchronizations are there, so that there should not be any kind of race condition. Constraint randomization, because in verification, as I told you, system verilog is mostly used for verification purpose. So this is basically having a kind of data manipulation, and for data manipulation we need good amount of data types with randomization facilities. So system verilog adds the constraint randomization facilities and lot of other new data types. So these are the features that basically attract these verification engineers to choose system verilog as a verification language, right? On the other hand, there is a verification methodology that are adopted by the engineers nowadays, because you can assume that if we don't use a common methodology, like suppose we have a team of 10 people and everyone is using their own methodology, so that will definitely not solve our purpose. What is purpose of engineer? That my design or my development can be reused again and again, so that the cost and everything can be reduced and the time efficiency can be increased. And if suppose we people are using our own methodology, different methodology, so the integration would be different, difficult. And if suppose I stuck in any of the step, then I would not be able to take the help of other candidates, right? So then the companies and the big people, they set together, and then they come up with one idea that why don't we have one common flow. Basically methodology is nothing but a flow. They will tell you basically what to be done at what time, when, and these all questions, right? Okay, so that basically help us to reuse the things and basically integrate the things in easy manner. So UVM is one of them. Earlier the people were using their own methodologies like OVM, RM, ERM, VMM, and so many things. But nowadays adoption is towards the UVM. So it's very powerful methodology which is composed of, which is having lot of ready-made things, which is having set of rules that to be used, right? So you can imagine, you can ask the question from yourself only, that if we do verification, if we write our own test bench or anything with our own methodology, then will any person, other person will be able to understand that until unless you don't teach them? Or can this work be integrated with other person's work? No, definitely the answer would be no, right? Okay, so the main advantage of using a common methodology basically to maintain the common workflow will be, which will be enhancing the reusability, high reusability, and the productivity will be high. Basically it is easily increased with the common methodology. So the UVM is again the new era, new technology, new methodology is adopted by the verification engineers or the VLSI engineers. And then certainly after the verification, the EDA tools knowledge, the MOSFET knowledge, and everything is required to enter into the VLSI field. Okay. So this slide itself, will give you the picture that what are the required languages that to learn for VLSI industry. Okay, so C and C++ is very mandatory languages, because without that languages, definitely it will be difficult to understand the Verilog
Ashik.
and system Verilog. Sorry, hello, is it fine?
Yes, sir, it is going fine. No worries.
Okay, okay. So C language and C++ language, this is, backbone of entire development. The C languages, suppose somebody is working in SoC, ARM processor, ARM Cortex processors and all. So there will require the C language, and sometimes we have to write the C code and then we have to import in the Verilog files. And so hardware software simulation will be requiring the knowledge of C language for the system level programming. C++, where the OOPS concepts are used. So certainly these OOPS concepts are used in test bench development, because a lot of time we will be using these all OOPS concepts. So C++ is ensuring that you are good at the OOPS concept. Verilog VHDL, this is starting of your RTL code writing. So mostly in the industry is adopting Verilog, but earlier the VHDL was there. So some basic knowledge of VHDL is also necessary. But the good amount of knowledge in Verilog is mandatory to enter into the Verilog, because most of the companies are now developing their products, developing their IPs in the Verilog. Okay, for RTL purpose. System Verilog for verification purpose. Basically, the entire test bench architecture and the verification environment will be developed in the system Verilog. And on the backend side, the UVM methodology, basically universal verification methodology, will be required. Okay, and apart from that, the knowledge of Linux, knowledge of scripting languages like Tcl, Perl, Python, these are mandatory. These are essential to enter into the VLSI industry. Okay, so this is, giving you an idea that if somebody of, from your side are willing to join the VLSI industry, then what are the prerequisite? Basically, they need to learn before, going into the advanced fields. So if anyone is willing to join front end, then they can go for the digital design. They need to understand the digital design concepts. They need to understand the C programming. As I told you, it's a backbone of front end. C++ and OOPS concepts are mandatory. Linux based, platforms you will be using, because all simulators will be used as a Linux based only. So basic exposure to Linux is mandatory. Basic computer architecture, like, because as I told you, this knowledge of computer architecture will be needed in the architectural description. This is a second step of your entire chip design flow, where the customer requirement comes and then we think to design the entire system, right? When you are willing to join backend, then again digital design concepts will be mandatory, because from digital gate level to the transistor level conversions needs to be done. MOSFET fundamentals, because now backend people will be working on the MOSFET level, transistor level, so they need to have the good ample knowledge of MOSFETs and analog circuits. Basic understanding of Linux, because again you need to work on the tools. The tools are Linux based tools. And basic computer architectures, that is mandatory for that, because if suppose I'm designing a SoC, so SoC will be requiring the computer processor also, CPU also, MCU, that is microcontroller also, some peripherals also, there will be connection points, that is the bus protocols also. So that is all required to develop an entire system, right? Some of the profiles that you can be thought of if you are willing to join the VLSI industry. For front end part, these are only few profiles I have picked up. There are lot many profiles, as you see from the entire chip design flow. Lot of manpower, lot of different levels the manpower will be required. So front end RTL design engineer, associate design engineers is one of the posts which we can apply for, verification engineer. And every profile has their own skill requirements, right? But the common skill requirement will be there, that everyone has to learn. Okay.
Sir,
So
I think somebody raised hand. Nihim Swami. Yes, do you have
yeah,
any doubt, Beta? Nihim.
can I expect some question from Nitin? He has raised the hand. Nitin Swami. Okay, so maybe by mistaken he has raised the hand. Okay. So verification engineer, FPGA engineers, then automation engineers, ASIC design or the associate design engineers, and DFT engineers. These are the different profiles that the front end engineers can think of and they can apply for. And similarly, the back end profiles are there. Some associate physical design engineers or PNR engineers, layout and IC design engineers, right? Okay. So what you need to do if somebody is willing to join, somebody is very keen to join the VLSI industry, they need to just go for these JDs, job details and job descriptions basically, and you need to see the skill requirements, because every job description has their own skill requirements, what are the skills they are needing, and you will find there will be common skills that what I dictated here. These will be the common skills. Apart from that, some job descriptions will have add-ons like VHDL, very low knowledge, or system very low knowledge, or UVM. Some skills will have like add-on knowledge of PNR, physical design concepts, or the TICL or any scripting languages, right? Okay. So up to now, if I'll be just happy to hear from you any questions. I can take 2 3 questions from the audience side. If anyone has any doubts, any queries, anything they want to speak, they're welcome. Over to you. Yes, please go ahead. Palak Srivastav.
Hello, sir. It is very
Hi.
delightful to be here. My question is, right now I'm in third year of electronics and communication branch,
Okay.
engineering. So, when I'm needed to apply for internship, how do I apply for the specific role? Like that is something that people right now say that because it's a VLSI related field, it
Hmm.
can not be very specific. Like I can't specifically apply for a job role, so how should I get the exact job description because it has so many
Yes,
layers
yes,
to it.
yes. So, first of all, just think on your interest, basically, that you are more interested towards the, front end, or you are more interested towards the back end, and that will come with the help of, knowledge of your subject. If you are good at like digital, you are good at programming, you are good at some logical development, then definitely the area that you are willing to join is the front end, where the concepts of microprocessor, digital design, programming will be needed. If you are good at MOSFET, that you are able to think the transistor level things, right? You are good at the devices level, right? That is transistors or diodes or so on. Then you can go for the physical design level. But again, you need to grab some advanced skills. That is very must for these 2 areas, right?
Okay, sure, sir. Thank you for informing me
I
this.
hope I am answerable to your question.
Yes, yes, sir. You
Yeah.
are.
Okay. Thank you, Palak. Any
Thank you
other?
so much, sir.
Any other question? Who is that NK? NK, you have any question? Please feel free, please open yourself so that at least you can have some kind of doubts, and these doubts can be cleared. Whether or not you join the industry, or that is secondary thing, but first of all you need to understand about the industry, right? What is the depth of industry, what is the requirement of industry, and how basically we can approach to the industry. That is very must, right? So anyone from audience side?
Good afternoon, sir.
It is very good afternoon, Krish.
Sir, I want to ask that how can we apply for internship in True Chip company?
This is not, to the true chip. You can apply to any company. They open up the internship facilities. They will give you the details on the LinkedIn or on their website career pages. So you continuously view their pages, you continuously see their LinkedIn pages, kindly like the company's pages also. Like suppose you want to enter into the VLSI, so you just take all the names which working in the VLSI and then follow these LinkedIn pages. So any update from these companies will come na, it will be visible to you people. Okay. And then try to see what are the requirements for that internship and how can you grab this internship. Basically now scenario has been changed. Whenever any company open up the internship opportunity, they also take the interviews, they also take the examinations, and they will be needing the specific knowledge, right? Like suppose anyone is opening up the internship for front end, so they will be definitely requiring the knowledge of digital, knowledge of Verilog, knowledge of system Verilog, and some basic understanding of UVM is also necessary. If somebody is requiring internship for the PD, then definitely the tool flow is mandatory, right? The system synopsis, ICC to compiler workflow, the PNR, floor planning, CTS concepts or synthesis concepts needs to be done. So you just work, you just see the LinkedIn continuously, see their career pages continuously. Okay.
Okay, one more candidate, I think, Abhishek Barar.
Yeah, go
To,
ahead, please.
yes. Abhishek, you
Abhishek.
can unmute yourself.
Okay, so if we don't have further queries, we can continue and we can take these queries at the end as well, right? Nitin
Yes, yes.
Swami, he is continuously raising the hand. So can I request Nitin Swami, do you have any question or you are just raising your hand by mistaken? Nitin Swami.
I think
Okay.
he raised and he forgot to put it down.
Okay. Okay. Perfect.
Yeah.
Perfect.
Yes.
So now the question comes basically how we can help you to become a good engineer or to enter into VLSI to develop your career foundation, right? So just to introduce, we as a future which we are having appearance in varieties of different projects. We are running currently the WIT Women in Tech with NXP Semiconductors, in which we are training the top notch girls candidate of IITs all over India. We selected only 75 candidates and we are giving them training with the NXP Semiconductor. We are skilling the engineering grads of different colleges in India as well as abroad in Vietnam. Okay, so we have tie up with institutions and we are providing the 6 month training programs to these candidates. We have very good program that is running with the Karnataka government, that is KVLSI program, which is basically to skilling the Karnataka students, engineering students. So in this program, we are hiring the Karnataka students only. This is only for Karnataka students, and we are giving them training and we are placing them in good companies. This is running in the Triple IT Bangalore, and FutureWiz is the training partner. We are running the BTech VLSI with the for 5 universities, and 2 universities are in pipelining. 5 universities are Manav Rachana University, LPU, Lovely Professional University in Punjab. Then we have Arni University in Himachal Pradesh. We have Manipal University in Jaipur, and we have the Chandigarh University, CU, that is in Chandigarh. So these are the 5 universities. We are running a BTech in VLSI program, and we are in tie-up with some more universities. And we have launched a good program that is Tejas in association with Roorkee IIT. Okay, so the IIT Roorkee is the service, is the certificate provider, and we are giving the training to the candidates. So these are the ongoing projects by which we are helping the VLSI aspirants to build their career, the foundation very strong that is required for VLSI industry. These are some of the courses that is running by FutureWiz. The team is running Silicon Threshold, in which we are, working on 3+3+3 plan. Just this 3+3+3 plan is basically, this is 3 months online, 3 months offline, hands-on, and 3 months paid internship. Okay. So once you do the paid internship, that I guess one fellow has got an idea na, that if we want to enter into VLSI industry and we are willing to join the internship in TrueChip, then you can join this course, which will give you the skilling process in 6 months and 3 months the internship. So that will help you to join the good companies, or you can retain in the TrueChip as well. We are running the Tejas program. As I told you, this is an association with IIT Roorkee. So certification of IIT Roorkee will be provided. Some faculty members of IIT Roorkee, some industry partner faculty members from FutureWiz will be teaching the course. We provide the summer internship of 6 weeks or 8 weeks, okay, in which the digital, Verilog, SOC design, these all concepts will be taught. We have some specialized programs for corporates, that is working professionals. So like some protocol based, learning is there, especially SVUVM, that is verification training, is for the industry partners or the corporates. Like recently we have trained 30 candidates of WD, Western Digital, that is SanDisk, right? Okay, so likewise we are, training the freshers of industry people also, and we are giving or conducting the fresher training for the corporates also. Like we have tie up with the corporates, so they hire the freshers and they send us. Okay, we will be training them and we will be making them employable. So this is what the learning path that normally we follow when anyone joins FutureWiz. Okay, if it is an industrial person or it's a student. Okay, so the course will be created for them. LMS will be given. The live sessions by experts will be there. Some in online sessions will be there. Then doubt sessions are there on weekly basis. Weekly basis there are assignments. There are tests on every 15 days. Okay, so the evaluation is there. We focus on the evaluation as well. Then we complete the subject. Again, doubt session with by industry experts. So this is the doubt session by the mentor. This is a doubt sessions by the industry experts. They will be telling. They will be giving the guidance to the listeners or audience, that how industry requires, what industry requirement is there. We go for the final test, and that scores are shared with the industries, and they hire the candidates, and finally we go for the certification. So mock interviews and placement assistance is there at the last step, right? So this is a complete learning path that anyone enters, in which we are providing the LMS is basically the full package will be given to you, in which you have the course material, you have the videos, lectures, which daily recordings are there, you have the assignments, everything will be there on your dashboard. So every student, every aspirant who is joining FutureWiz, they will be having one LMS, unique password and unique user ID for each candidate. Why anyone wants to join any VLSI, training institute or any industry? So what is the difference? Basically, the FutureWiz is providing you. So we have, purely a project-based learning. We don't focus much on theoretical concepts. We focus on hands-on, because ultimately you should be very good at hands-on. We focus on the project-based learning. A lot of projects are to be, assigned to you. The faculty members or the industry people, they are having more than 10 years of experience, means they are very good at the delivering. We have international internship opportunities, like in Vietnam we have office, we have collaborations with other companies also. So that is optional. Basically, if anyone is willing to join, means they have to choose this optional internship facility. The every lab session will be on the industry leading tools. Like for front end, if we are talking, then you have to choose, or you have to work on the Questa Sim or Cadence NC. If backend tool, then the Synopsys ICC2 compilers are to be used. We have very good collaboration with place companies also, with the core companies, big product based companies also. So our candidates are placed in good companies like Synopsys. If you see our footprints, many candidates are placed in Synopsys. They are in the Tessol, they are in the Maverick also, Mobiville also. So a lot of good companies, TrueChip is one of the good hiring partner for us, because this is same company. So most of the candidates are hired by TrueChip itself, and some candidates are going in the other industries also. We provide the 2 to 3 months internship, that is again mandatory for everyone. So this will give you the industry exposure. And the candidate who is registering with us, if they want to join any VLSI conference like VLSI D or semicon conferences, so they are free to join, means the pay will be provided by us. So these are the features provided by FutureWiz to any aspirant who is joining us. Some companies, some other institutions are providing some of the features, or some companies are not providing. So that is what the comparative analysis. This is something that anyone, if joining any institution or any company, they need to think of, they need to see, right? Okay, so I guess I am done with the all the features, all the things that is needed to just uh, brush up, basically to give an crux in your nutshells, right? Still you have any kind of doubts, any further assistance, so you can visit our website anytime, www.futureviz.co.in. If you need any kind of assistance, whether you join FutureViz or not, that is secondary part. But if you need any kind of guidance, you are free to call Ranveer Singh. He is the manager for entire program. Myself, I'm the senior knowledge associate who is dealing with the academics only. Mr. Sanjay, who is my colleague, who is again dealing with the academics, and Varun, he is the main pillar who coordinates with the students, right? So thank you very much, guys, and I'm opening myself for your queries. I request everyone to feel free to ask the questions that are relevant to this session, this webinar. I'll be hearing. I'll be happy to answer your queries. That's all from my side. Thank you very much. So I would love to address few queries from the audience side, if any.
Yes, is there anyone have any query? They can like unmute yourself and they can discuss it with the mentor.
Please open up yourself. Don't feel hesitate. Ask queries. Yeah, please. No queries?
I think there's no query. So Aditi,
Okay,
you
so
can.
then let me just pick up few candidate to get some idea whether they have got something in the with this session or not, right? And at the end, I would say thank you to everyone who joined us at the Gandhinagar booth, who joined us here also. You are welcome to discuss anything regarding your career shaping activities anytime, any day, right? So let's just have quick discussions with few random candidates. Okay, uh just pick up in taking Chetna Bharadwaj. Can you just tell some few words, okay, say some words about this webinar? Was it worth for everyone? Chetna Bharadwaj. Please unmute yourself and feel free to speak. Chetna Bharadwaj. Okay. Thank you. Thank you. Yeah, you can type in chat box as well. It's totally okay from my side. I'll be happy for that as well, right? So just feel free to type if any suggestions you want to do, you want to give, that is also okay. Jayant, can I hear from you? Jayant, Okay. So I guess then we should wind up this session. Okay. Thank you very much for attending this session. Okay.
Thank you so much, Shashikant sir. We are deeply grateful to Shashikant Sharma sir for his insightful presentation. Your expertise and knowledge has been truly valuable to us, sir. And a special thanks also to FutureWiz team for their tireless efforts in making the webinar a successful. And thank you everyone, all of you, for taking time to be here, and your presence makes this event truly special. Thank you so much, everybody.
Thank you very much. And I request everyone to turn on their cameras for few seconds so that we can have a group photograph if they are okay, right? That will be good. Okay.
Yeah,
Yes.
kindly everybody turn on their cameras.
Yeah. Please. Okay. Thank you.
Thank you so much,
Thank you
sir.
everyone. Thank you.
Yeah, thank you everyone. Now, have a good day. Thank you very much for listening us patiently, and we'll connect back to you.